So good evening, everybody, and welcome to vBrownBag. It's October 24th, and tonight's presentation is going to be Introduction to Cloud Automation Services with Cody De Arkland, part of one of the one of my VMware coworkers, and one of the best automation guys I know.
Oh, Guy.
Yeah. Uh, just as a reminder, there are other vBrownBags out there as well. If you want to reach out to us, make sure to hit us up on Twitter, or if you have any questions, reach out at vBrownBag or hashtag vBrownBag for any questions, either live during the show or just at any time. My name is Louis Ayuso. I'll be hosting for tonight, and I'm going to give control over to Cody here.
All right.
You presenter.
Fantastic. All right.
I'm told we're doing all live tonight, live demo. So good luck.
When you say it like that.
Oh, doing it live doesn't always work out great.
If you're going to do it, might as well do it right. So, are we able to see my screen?
We can see your screen, and we are recording. Go for it.
Sweet. So we'll just dive in and start talking a little bit. I do these. The vBrownBags are a ton of fun because we don't have to do these as like super formal like demo scenarios where we're walking through things step by step and making it very like boring and markety. We get to get down to like the tech details and just have some fun. So I didn't do any deck. I didn't do any presentation stuff. We're going to jump into the product directly and just talk super plainly about what it is and how it achieves the goals that it targets. So Cloud Automation Services is broken up into three products: Cloud Assembly, Service Broker, and CodeStream. Cloud Assembly and Service Broker have a very tight integration between each other. CodeStream is a little bit off to the side, but I'm going to talk a little bit about how CodeStream really can play very well in the Cloud Assembly space and kind of complement the whole show. It is a automation product, right? So people draw a lot of parallels to VRA's automation. We try to stay away from that because really VRA and CAS solve different problems right now. CAS will grow and it will change and it will eventually have a lot of the same functionality that VRA has. But for today and for the immediate future, they solve different problems. And when we talk about different problems it solves, VRA is heavy in the governance space. It's about approvals. It's about how to make a platform that's end user consumable. Whereas CAS is more dedicated to the developer. It's more tuned for the advanced user who's trying to get workloads in public cloud first. VRA can do some public cloud, but it's not aware of things like public cloud constructs like Route 53 or RDS or S3, things like that. Whereas CAS was built from the ground up to support the cloud from day one. John Schulman likes to say that it was born in the cloud and bred in the cloud. It's like the Bane statement from Batman, that you merely adopted the cloud, but CAS was born in it and molded by it. So it's a funny little quote from John. So we're gonna jump in and start playing with content. I like to start off in a service. Oh, go ahead. What's up?
So we see this discussion all the time. Is CAS going to be the official like nickname for this, or are you going to do it like VRA and CAS?
I usually call it CAS for short, just because Cloud Automation Services is really long, and if we call it the aforementioned internal code name that everybody knows, I get yelled at. So we're gonna call it CAS for short to avoid myself getting hit by somebody.
So. It's always funny because you think about like when people talk about Vernie, like you can't call it that. Go ahead. Sorry.
Let's be real. Odell is the only person who says you can't call it Vernie. Odell is the only one who says that. Everybody else is calls it Vernie. So, yeah. Anyways, so when users come in, I like to start with Service Broker because it's really where your end users are going to come in first, and they're going to see catalog items. Service Broker is pretty basic right now. It's really kind of tuned to show just very specific blueprints. It's going to grow, and it's going to become kind of front end for a number of different services, things like Helm charts and things of that nature. So for right now, it's really focused on Cloud Assembly blueprints. So it's empty right now, little sad face. Aw. So we're going to go ahead and add some of the blueprints in that I've already built. We're going to hop over to Cloud Assembly in a minute here and show all that fun stuff. But I wanted to just start off with showing how easy it is to get those blueprints in. So we do new content source. We have blueprints. We'll go Cody's VPs. You see it automatically discovers 7 items, imports them. Now you saw on that drop down, we also have CloudFormation templates. So we have the ability to publish out AWS CFT. So if you've already invested a lot of energy in building out really cool CFTs for your organization, we can consume those and use those as catalog items very, very easily. Azure resource images are going to come next. So ARM templates, those will be coming soon. And then as well as other stuff down the road, but those are kind of the immediate deliverables. So we'll also add in those CFTs that I have. I stored mine in a S3 bucket, so making it really easy. Cody De Arkland, CFTs, public, validate, grabs 3, drop it into my AWS account on the west side. We'll share these out to projects. What a project is, projects are the marrying of compute resources, which are cloud zones, which I'm going to show in a moment, to users. So you create a project, you add users to the project, you add cloud zones to that project as well, and the users that are in that project can now see resources to provision to. So I have these 2 sets of items. I'm going to publish those out to my lab project. And now if I head over to the catalog, we see fun, nifty things. So I can pop in. I get a little form that pops up after it finishes loading. There we go. Now, this is all stylable through custom forms. So a little while back, Jad and I did a custom forms demo, and we talked a little bit about the future of custom forms and where it was going, and this was kind of what we were hinting at, that the new platform heavily uses custom forms. So this is an unstyled form. If I come back and I hit administration, I go into content, I can see all of my different blueprint items, whether or not they're Cloud Assembly blueprints or CFTs. I can select one, I can come in and do a custom form around it. I can start to transform this form into something a little bit more friendly. So I could do decision-driven provisioning around if it's a prod server, it automatically fills in different content. Anyone who's done like a lot of XAS work, be very familiar with the stuff that we try to do inside of custom forms, right? Trying to make it easier for end users to get resources without IT jargon wrapped around it, and have a lot of automation run in the back end. So we're not going to go through that because styling custom forms is not that exciting, if I'm honest. So that's Service Broker at a high level. I can go in, I can request, I can see deployments. I have a deployment in here already. I'm going to show what this little bundle of joy is here in a few moments, but we will now switch over to Cloud Assembly. So I hit the little grid icon, I go to Cloud Assembly. Cloud Assembly is essentially the provisioning engine for the platform. So all of your blueprints are kept in here, all of your mapping objects are kept in here. It also is where all of the discovery takes place. So when it finds all of the various cloud accounts and objects within cloud accounts, that happens within Cloud Assembly. So the first screen you land on when you log in is the cloud account screen, and this is where you bind those different environments, different accounts. So in mine, you can see I have my home lab, I have my home lab NSXT, I have an Azure account, then I have a AWS account. I have some tags applied over here. Those shouldn't be applied there anymore because, if I'm completely honest, they're useless on the screen. This is going to go away eventually because tagging at this level doesn't do anything. But tags in the platform, you'll see them referenced a lot and used often. Tags are how we place workloads in given environments inside of Cloud Assembly and CAS and the provisioning engine.
Are these tags living only within here, or are they dropped down all the way into whichever infrastructure they're in, so that you could see them there as well?
Yeah, unfortunately, these are specifically in Cloud Assembly, so they are Cloud Assembly constructs. There's talks about where those are going to push to long term, but for now and for the foreseeable future, they are tags that live within Cloud Assembly only.
More for like an asset management within this service.
Well, so not I wouldn't say so much asset management here, but specifically what tags are used for within Cloud Assembly is the placement engine, right? It's how the workloads place. So I'll show a good example of that. Each one of these are added create have the option to create cloud zones. Cloud zones are a direct comparative to reservations in VRA, but with infinitely more flexibility around how they're placed. If I pop into cloud zones and I go into my lab environment, you'll see that I tagged the compute resources here with Cloud vSphere. When I use that tag on a blueprint, the placement engine understands, okay, I need to place this on this zone, right? So think about this, Grant Orchard has a great demo about this where he uses tags to apply different compliance level rules. So if it's a HIPAA workload, it goes to a specific cluster, has specific policies applied to it, specific storage that's sectioned off. If you work with VRA a lot, you know that it's kind of challenging to pivot workloads very easily between multiple clusters. There's a lot of work that goes into making that happen inside of VRA. Inside of CAS, it's very easy. I pop into a cluster, I hit a tag.
Okay, yeah, so it's like SPVM, but for workload placement.
Absolutely.
Across different places.
Great comparative. So I can apply that tag, and now if I apply this tag on a blueprint, CAS understands that I need to place this workload on this cluster.
Is it at the blueprint level only, or can you do it at workloads inside of like individual objects inside of the blueprint itself where it would span across multiple zones?
Absolutely. So it's not a blueprint level construct, it is a object level construct. And that's a really good, we're skipping ahead a little bit, but it's totally fine. No, it's good because in VRA, for a lot of reasons that make sense, VRA treats the blueprint as the kind of first class object, right? So when you want to change things within the blueprint, there's very few things that you can modify within a VRA blueprint and have it impact the machines in a smooth way, right? The blueprint in VRA is essentially everything about it. That's why when you work with like the VRA Terraform provider, you're interacting directly with the blueprint object. You're not interacting with the machines inside. You're ultimately interacting with the blueprint object. Okay. In CAS, that model has changed, and now the deployment object is really getting past like the nerd knobs. Really, the deployment is just metadata. The objects within that deployment are the first class object. So when we start to apply these policies, CAS sees those individual items, the load balancer, the disks, the individual machines, the network. These are all first-class objects to CAS, and it understands what to do with them. As such, you can iterate on those, change those, make them better, add more workloads, and it's fine because it doesn't care about the overall blueprint. It cares about what's happening to the machines within the blueprint.
Okay. So there's one question from Jason is this an AWS, a VMware on AWS only product, or how did we get to this web console?
Absolutely not. So this is a software as a service offering. I should have mentioned that way earlier on. This is software as a service offering, so it's hosted in the cloud. But as you can see from that cloud account screen, I'll discard those changes. I have my on-premises data center here. This is sitting 7 feet away from me in my closet. This is my NSX hosted within there. Like, this is my home lab, right? This is what's bound to that object right there. But then I also have my AWS. In my TM environment, I have my VMC cluster attached, so I can provision there if I want to. But no, it's absolutely not dedicated to VMC at all.
And this is all accessed through the cloud.vmware console, correct?
Yep. So, for example, if I go console, not Costco, that doesn't help anything. Console to cloud.vmware.com, it's going to auto sign me in because I'm cached, obviously, but all those icons come up. So once you log in, you see them there. It's available for a trial. So like anybody that's listening in, there's like a 30-day trial that exists for this product. You can go in and request a trial. I know several people in the vExpert community have gone out and just requested a trial. The cool thing is you do get contacted by product management, so they'll get feedback from you. So even if you're not buying, you still get to give some feedback and have a conversation with them about what the product's doing. I would highly encourage doing it. It's definitely a good thing. But moving back to our little adventure. So cloud zones are created when those cloud accounts are added. I should add that when the cloud accounts are created, there's also a discovery process that kicks off that discovers every type of resource in the environment. This is most helpful for not just provisioning workloads, but also for onboarding workloads, right? So I discover all the machines across my environment. I can bring those in and turn those into deployment objects within CAS. So if I want to make these into managed objects that I can perform day 2 actions on that are going to become blueprints, I can absolutely do that. And we do that through this onboarding plan screen. Anyone who's done bulk import in VRA knows that it's the shining example of the best version of onboarding workloads ever. That's a joke. Don't mean that at all. It's not the best way to do it. It's very frustrating to onboard things via the bulk import tool. It's very, very smooth in CAS. So if I open this up, you can see that I've created an onboarding plan here, and I've started to separate these out into individual deployments. I even added my VRA cluster as a deployment inside of CAS because I'm snarky like that. But I could run this, and it would create a series of deployments similar to the one that we'd shown for that Puppet AWS demo that we're going to talk about. Those would show up in that list, and I'd be able to perform day 2 actions on them, power on, power off, apply power policy to them, things like that, because they would be essentially under management at that point, right? So I have a console cluster that I've added in this. I have a development stack. So if I hit run, it's going to go out and create those deployments, but I can also have this generate blueprints for me. So it'll look at those machines and it'll say, what does a blueprint look like in this case? So if I do this, it will create a blueprint and drop it into CAS as something that can be consumed. So it's pretty cool little feature. There's a lot of work going into this onboarding feature. But back to Cloud Zones. Cloud Zones are where we set up the actual compute resources that systems are going to provision to. Things get interesting from here, though, because we start to build out these mapping relationships. CAS was built from the ground up to be a multi-cloud product, right? Like the public cloud endpoints were built first. So from a development standpoint, VMware was able to provision into public clouds with CAS long before we were able to provision into vSphere. And that goes to show kind of the commitment that we have to getting the public cloud right in CAS. But part of that is how do we provision to multi-cloud without making it complex for users? And where we landed, for better or worse, which I think is for better, is these mapping constructs. So when we look at a small, we know that a small in AWS is not labeled small. We also know that you don't just pick memory and CPU in AWS. You use like a T2 small designation. In Azure, it's standard B1MS, but in my on-prem data center, I'm focused on my memory and CPU usage, right?
Okay, so you're standardizing this across all of your resources.
Exactly. So now when that placement logic kicks in, so when I do a cloud vSphere, it comes in and looks at the sizing and says, okay, for a small, I need to use this. Here's what I apply. That same concept applies to image mappings, and that's where it's kind of the most pronounced is in AWS, there's about 500 different AMIs for Ubuntu 16. I apply it here, the one that I actually want, like kind of the official Ubuntu 16. Mm-hmm. Then I also define out my on-prem as well as my different Azure ones as well. So you were creating these relationship mappings that allow us to really be cloud agnostic. So when we go into the blueprint screen, which I'm going to click on immediately after this, and we start to define out what a blueprint looks like, we plug in that image Ubuntu, and it understands how to go out and pivot between those clouds and pick the right AMI, template, Azure image, whatever, based on the cloud that you're picking. So we'll hop over to blueprints now and have a little fun there. So you're seeing this is my actual lab environment where I develop stuff and play with things. So there's a lot of different stuff in here that's not fully working, but most of it is actually pretty solid at this point. This was the newest edition, so I'm going to start off there for fun. I actually discovered that content library support was pushed in, and that's kind of the glory of it being a SaaS offering is we're able to add this functionality without the users having to go and upgrade to VRA 7.9, right? We're able to push this functionality in, so all of a sudden, when I went into my image mappings for my on-prem, I was able to see all of William Lamb's content library. So this actually deploys out 3 ESX hosts into my environment. So if I hit deploy on this, it spins up the demo, or it spins up the deployment, not demo, which is a demo still. If we come in, look at history, we can see the decision process it's making around where to place objects. If we come into allocation on one of these machines, we'll see how that tag-based placement works. There we go. So I selected vSphere, this project. I had been very specific that I wanted a vSphere object, so it automatically provisioned my vSphere cluster. If I go back and pick another one as a better example of showing the placement logic, go back and use this AWS one that I spun up right before. Go into the allocation. There we go. This is better. This one was an AWS build. We can see how the placement logic decided to place it on AWS. It initially looked at the project, which was my lab project. It knew that within my lab project, I had 3 cloud zones configured. I had AWS, I had on-prem vSphere, and I had an Azure. It's a medium-sized build. There was no flavor mapping for medium, so Azure got swept off the table. That left just AWS and on-prem vSphere. It knew there was a medium, it knew there was a Ubuntu in both, but when it got down to the actual cloud zone selection, it noticed that there was a cloud AWS tag, so it applied it to the AWS and ruled out the vSphere. So this tool is awesome. We use this every single day to actually test deployments, to troubleshoot why stuff is placing where, so on and so forth. It's a very, very useful tool, and it's very cool to be able to visualize and see how these workloads are placing based on the decisions you're making. Just popping into blueprints. If we go into vSphere, we can actually see that.
Now, under the table, you're connecting to that content library at the CAS level? Did you have to actually connect to it, connect that same content library to the vCenter server in the lab?
Yeah, so I did have to map that. So I had to subscribe to the content library inside of vSphere, right? So once it was there, the CAS discovered it from my environment via something called the remote data collector. And once it discovered those images, they were available to map within Cloud Assembly.
Okay. And so, one of the questions on this is, could it tie into like a VRB or costing product? So does it tie into like the VRB on premises or the SaaS version as well?
I can't answer that question.
You can't answer that question.
I know the answer to that question, but I can't answer that question.
Okay.
So there's a lot of movement in that space right now. There's a lot of stuff. There will be obviously some costing components. There will be some functionality for costing. Where that maps to and how it comes back is to be announced. There's a lot of really cool stuff going on in that space that I wish I could share more about. Just can't share it right now.
Okay.
Womp womp. It's no fun when I have to answer it that way.
We'll consider that a live lab failure.
No, that's absolutely not a live. I will not accept that as a lab failure. Anyways, moving on. So that's a very basic build, right? We're deploying 3 nested hosts. They're off and running. They're doing their thing. It's about to finish, actually. So we'll pause on looking at this build for now, and we'll jump over to something a little bit more interesting. So I have this Ubuntu build that uses Puppet open source. I've been trying to do a lot of work with Puppet open source because I think it's getting a far too little attention, given how powerful of a product it is and the things it can do. And I was a long time Puppet hater, so if I'm coming back and saying that it deserves some attention now, that I like to think that means something. But let's break down what's happening on the screen right now. On the far left, we have all of the components that we're able to add to this blueprint to make as objects in the environment. There's a lot of cloud native services that we have built into the product now. Things like we have Kinesis, EMR, RDS, IAM policies, Lambda. Some of the big callouts, the ones that are like probably most helpful in short term, are being able to add an RDS cluster. So I can have an RDS cluster provision as part of this deployment and actually consume it. We have a couple of demos that actually use that as the backend database, right? So we're able to deploy an EC2 instance to AWS and have that RDS cluster be the backend database for it. If you had like a direct connect setup, you could deploy that on-prem and have the RDS be the backend and then connect over your VPC via that direct connect. It'd be messy, and why you would do that, I don't know, but you feasibly could do that. We can apply Lambda functions. So if you had some form of integration that you were doing that was using Lambda, you could drag a Lambda function out, have it run alongside that deployment as kind of a form of extensibility or a form of integration. The one I'm super excited about is the ability to add Route 53 zones. So I have a bunch of demos. I bought a domain, vmw.cmbu.com, and we use that for like demos. So now if I drug this out onto the canvas, I could map this to that object. You'll see that YAML updating on the right as I change it, and I could add in the DNS reservation. So I have a host name tag on here. It would be very easy for me to come in and have that input be a part of this. So now that would actually push out that reservation. I could have it be an A record. I have to grab the zone ID. It's VTMM AWS US West 1, right? And if I went out and I have to add one more value in there, which is the TTL, And if I had the zone ID handy, which I don't have it memorized, so I'm not going to plug it in. If I went in and deployed this out to AWS, it would actually create that reservation against the IP address that was provisioned into AWS. So it's really easy to actually have an end-to-end useful service using cloud native functions as well as deploying out to a cloud. So I'll delete that out. We're not going to go down that path too far right now. You'll notice that there's a little bit of a styling difference between some of these icons, and there's also a different header for those. I'm using the cloud agnostic objects. Everything that is available in CAS, and this should get people really excited, everything available in CAS is backed by an API. If it doesn't have an API, it doesn't make it into the UI. That's a very big departure from VRA, where some stuff is API driven, some stuff is .NET constructs that don't have an API. Everything is API driven. And the reason I highlight that in the context of cloud agnostic blueprints or cloud agnostic objects is because each one of these objects from an API layer understands how to provision those across multiple clouds. So when I drag this load balancer out, in the backend code, CAS understands what an ELB is, it understands what an Azure load balancer is, it understands what an NSXT and an NSXV load balancer is, understands how to deploy a tier 0 router or tier 1 router, I was confused, understands how to deploy an ESG. It understands how to make this load balancer object work across every cloud. So if I just switch this tag placement, which we talked about earlier, from AWS to vSphere, this blueprint doesn't need to change at all other than that. It understands how to provision that load balancer out, assuming that you have a NSX endpoint attached to it. Make sense?
Mm-hmm.
Awesome.
So one question I have, so seeing all the things you can do is always great, but are there some common workload types or blueprints that people have been looking for that maybe they can't do just yet, but are coming? Things that would be a little difficult. You could build it. You could literally build anything if there's an API for it, right? But are there things that you're still waiting to people are asking for that we're waiting to see be introduced?
So there's a lot of stuff that's coming to the product, right? I can only go so far into futures on these calls, but like obviously we only have the AWS cloud native constructs here today, right? So Azure is limited to machine disk. So there's cloud native constructs for Azure coming. There's things like Kubernetes integration coming. So there's a lot of stuff that's coming to the product. Right now the product's in what we call initial availability, which means that you can go out. It solves the main use cases that we targeted. The main use cases being public cloud first, private cloud availability, and the ability to provision between multiple of those. That was kind of the core initial availability use case. When we start to get to general availability, where all of the other functionality is in place, because like there's some things missing that you would assume need to be in a cloud management platform. Approvals, right? Some level of approvals need to be there. Some level of policy engine needs to be there outside of just tag placement, right? These are all coming as part of GA deliverables. Initial availability means that it's available to do the kind of base level provisioning, base level configuration of an environment.
Okay.
So there's a lot of stuff coming.
So from like a NSXT perspective, when you're working with some of those different products, any limitations in that area?
No, not necessarily. I mean, obviously, like firewall rules aren't here today, right? Okay. So the ability to work with the firewalling within like NSXV and NSXT. That capability is not there today. Stuff like that is coming now. When I say it's not there today, it's there. It's just a little bit more kind of chunky to use. So if I go into the network profiles and I look at my core environment and I go over to security, I could add in security groups from my NSX environment. There's a lot of work going into making this a little bit of a cleaner overall experience and ways to make this a little bit better. Okay.
Yeah, closer to more like a consumer-friendly version of adding and working with and managing them.
Exactly. So that stuff is coming to the platform.
Okay.
Stop turning this into a futures call, Luis.
I just gotta see it. I gotta poke and find the holes, man. This is a vBrownBag.
That's fair.
I also have to try to break your lab, so I have to kind of guide it there.
Well, let's see if we can break it. So I provisioned this earlier. Let's see if it loads up. Oh, look at that.
Nice.
Except for it's a massively huge logo, so I can fix that. So the reason I wanted to load this up now, is this is running that open source Puppet manifest that I ran. So this is like available. Anybody who has like a VRA environment or a CAS environment could use this content right now and replicate the same thing that I just did. In CAS though, from a blueprint perspective, we have this thing called a cloud config. And cloud config is based on something called cloud init, which is kind of an industry standard agent, quote unquote, that's used to do customization in the public cloud space. So most AMIs come with it installed. Most Azure images come with it installed. It's on most things in GCP, and you can install it on on-premises workloads as well. This agent, though, gives us, it's like, think of it as like the customization spec on steroids. So I define out the host name, which I piped in from an input. I have a couple packages it installs, so it goes out and does, since it's Ubuntu, it goes into does an apt install, wget, apt install get, and then it runs a series of commands. In this case, I'm using it really just to straight bootstrap a Puppet run. So I pull down the Puppet repo, I add the Puppet repo, I do an update to apt, I pull down the Puppet agent, I clone down my Puppet manifest, which is here. So anybody, this is an open repo. So anybody can go and take a gander at this, which I'll open up on the screen so everyone can see. So you can see the actual Puppet manifest in plans. There you go. That's essentially the Puppet file. Clones down that, runs the Puppet apply against it, and then restarts Nginx because the Puppet manifest is having problems restarting that. So I brute force restart Nginx to get it to pick up. This will provision across multiple environments. So if I do a deploy on this now, I switch that tag to vSphere from AWS. Just give it a silly host name. Go on deploy. Now I do want to show something kind of cool. While that's provisioning, I'll go back in here. We'll close this out. We're going to make just a simple demo blueprint. So you come from a VRA background. You've used VRA quite a bit. Have you ever deployed an EC2 instance in VRA before?
Not personally, no.
So it works.
It's pretty neat because you're doing it's a common kind of post config framework, right? So it's the same across all of your public and private clouds, and you don't have to worry about making a different type of config for each. And it's one type
Correct.
of config you can use no matter where the placement happens. And then that just means it's a placement tag after that.
Yep, exactly. It's part of that cloud native story. Now there are some, because this is vBrownBag and I'm not going to market it, I'm going to be super honest. There are some times where that falls apart, right? Because there are some things that you would want to do on premises in that run spec that you wouldn't want to do in public cloud. So for example, if I wouldn't push a DNS record into Microsoft DNS for public cloud. Right? I would only do that for on-prem. I would be using some other form of resolution for public cloud, like Route 53, and then doing calls out to Route 53 to handle DNS. So there's some places, for the most part, you're right. It works really well for that, and there's a ton of example stuff out there. But this is something that we're giving internally as feedback, that we need some ways to handle this when you have things that you only want to perform on one cloud that you don't want to perform on others. So like conditional execution stuff, that's a common conversation. But then again, some of that's
like a switch statement for when you're doing one type of object, one type of cloud versus another.
Absolutely. So conditional execution, right? So if I do this in Code Cloud AWS, I hope there's somebody on who has done AWS provisioning in VRA before other than Jad, but Jad will attest to this also. This is a very simple blueprint, right? Nothing is really happening in it other than deploying an EC2 instance. But if I go out and deploy this, you're going to be shocked at how fast this actually deploys and is an like an EC2 instance. It frequently will deploy an AWS EC2 instance in less than a minute. Right, where it goes from nothing to a functional available AWS instance in a minute. And Cloud Init only takes 10 seconds to run, right? So if I added on the ability to push like an SSH key to that and be able to connect to that SSH key, it would be still very quick for me to be able to get into that box and actually start to do relevant things. This machine that we started up here, this Puppet deploy example, is running. So if we pop in and we look at the actual deployment, I think it was tagged.
I could take your word for it, but I did start a timer.
It's fair.
Yeah.
That's fair. There we go. So this one, I believe, is running right now. It's waiting to bring up the interface, so we'll let that run its due course.
Jad says that he attests to this.
There it is. So that's done now. So that AWS.
I'll give it to you. It was under a minute. Just barely, but it was under a minute.
To be fair, it finished before that. If we go in and look, we can see the actual seconds here. If you want to get all technical about it, it took about, what is that? Actually, it took about 30 seconds because it was at 11 and finished at 41.
All right.
Hater. So talking about like iterative deployment, right? So when I talked earlier about being able to change, what if I wanted to bolt a disk onto this? All right, so I can drag out this disk, I can map it onto the object, give it a capacity. It's got 1 gig now, just up it to 10. I need to deploy. Now I can create a new deployment from this, or I can update an existing deployment. So I can update this deployment. It'll tell me what it's going to do. It's just going to add on a disk, and it'll deploy it. It changes nothing about the machine aside from just bolting on that new image.
So when you go to do that update or deploy, that's looking at everything you've ever deployed using that blueprint, and then it provides that.
No, it's that's everything in the environment. Period. Now, if I tried to update a on-prem deployment, right? So say I tried to update this that nested ESX host, it'll actually tear down the whole environment, right? So it's going to tell me that it's going to delete all of those vSphere objects and the network, and just re-provision it with AWS because those were on-prem builds, and that's in cloud, right? So the engine, the provisioning engine says, I can't make this work. I give up. I'm just going to nuke it from orbit and start over, right? But when it comes to the individual EC2 instance, it says, oh, it's just an EC2 instance. I can bolt a disk onto that. That's fine. And it successfully bolts on the disk, right? So now this has a volume attached to it. Conversely, if I came in and I wanted to add on another machine and hit deploy, it would just pick up and go, right? It would just add on that machine, no problem. Add on my constraints, cloud, AWS, deploy, update existing. It's just adding another machine and adds another one to that deployment, right? No big deal. So it gives us the ability to iterate on existing deployments. Another very cool thing about the Blueprint engine is we have the ability to version these blueprints, and that allows us to have a history behind what that blueprint is. So if we go in and look at some of my other blueprints that I've done a lot of work on, multi-cloud load balancing is a good example. I go to version history. You see I have a ton of different versions here versus this current existing draft. If I come in and I do a diff and I select version 1, we can actually see all the ways that this has changed over time from that version 1. So you can see I've added in a whole nother machine. I've added in cloud config. From a graphics perspective, we can switch this from diff and go diff visually, and we can see how it's changed. So the version 5 has an additional machine, whereas this one did not. There's obviously changes to the website. So it has a very comprehensive differentiating engine in it, but it also is going to grow to have Git integration behind this as well. So that's going to be a very cool feature. So backing out. Now, it's important to note that when we talk about Service Broker and we talk about publishing out these blueprints, the only things that show up are ones that you've released. I highlight this because it's a massive pain point in VRA today. If I'm an administrator and I'm going to work on a VRA blueprint, say I have a functional SQL always-on cluster blueprint that is working, but I want to change it. I want to add some other bells and whistles. The most likely path as an administrator to updating that blueprint is you're going to clone that blueprint, you're going to entitle it to a entitlement, or you're going to add it to an entitlement that only you or your administrative team have access to, probably living in your admin team business group. But you do that so that the users can't see it. You're going to make all your changes to that blueprint, make sure it's all good, make sure it's all working. Then you're going to delete the old blueprint and entitle that new blueprint to those users also. It's a very clunky process of like a shell game of moving this blueprint around until it's in a better place. With the way Cloud Assembly approaches it, we can have blueprints that are draft. So as an admin, we're in here, we're working, we can deploy from this interface and users aren't seeing it. But when we're good and we're happy with our functionality, we can come into that versioning interface and we can release the blueprint. So these are all unreleased now. If I hit release, that blueprint becomes exposed into Service Broker or available to expose in Service Broker if it wasn't exposed previously. We can also expose multiple versions. So say you have a blueprint that version 1 is a single node SQL cluster or SQL deployment, but then version 2 is that always on cluster, and you want to expose them both as the same catalog item, but you want to create a drop down or a selection criteria between those different versions. That's possible as well. So there's a lot of flexibility in publishing and a lot of flexibility in iterative development on blueprint items. And that was one of the biggest use cases for Cloud Assembly, was we need to give people the ability to iterate and transform their deployments as time goes on, because automation is a very fluid concept, right? It doesn't always, nothing's ever done. It's just good enough for right now, right? You're going to add on additional capabilities to your oldest blueprints as time goes forward.
So how do you make sure to keep all this clean? Because if you're iterating and keeping track, are you providing a way to make sure that, hey, these ones that are old aren't used anymore? Nobody's got a deployment based on this one anymore. Is there a way to, like, hey, you should clean this up and stop making these available?
Not from a existing like an existing deployments perspective. Existing deployments are going to be based on their blueprint that they were deployed, right? Like that's just how it is.
No, yeah, what I mean is, when you look at like that version history, what's released and unreleased, even if it's multiple iterations of the same blueprint, just different versions, right? Is there a point at some point where you say, you know what, nobody's using this iteration anymore? Maybe all the deployments that were based off of this are gone. Do you still need this one released?
Yeah, there's not an engine necessarily to tell you that and say like, hey, your usage of your blueprint is, there's 7 deployments using version 5, but there's 0 using version 1. Like recommendation engine, there's nothing for that. That's a good feature request and a good idea. I think that there's a lot of value around that, especially around showing, being able to show reporting over consumption. So I'll definitely take that back, because that's a solid idea. But the short answer is no.
No, okay. So then, can you update a deployment with a new version of the blueprint? So like if you deploy it on version 1,
absolutely,
you have version 5, can you go and use version 5 to update the version 1 deployment?
Yeah. So when I pop into like version 5 on this, right? So right now, if I restored this blueprint to version 5 and I went in and did a deploy, I could select update and select one that was deployed under version 1 and update that to version 5. Absolutely. I sense that was not the question.
Oh, that was totally the question.
Okay, good. All right.
No,
fantastic. Crushing it.
When you're doing that, say there were some custom configurations on the VM. The VM exists on both blueprints, but the custom configs change. Would you be removing and then redeploying it using the new configs because there was those changes on that individual type of object? Or
it would probably, for like things like installation changes, package changes, those would probably end up being a reconfig, right? So it would the placement logic would probably, the engine would look at that and say, okay, the cloud config has changed. I need to burn this machine down and redeploy it because the software has changed on it. That would probably be a burn down scenario. Like, so for example, if you had an existing web server and you decided I want to consolidate and run my database on my web server also. So you change the deployment to have that Postgres install alongside your Apache build. That would if you did a redeploy and you updated an existing build, it would burn down that existing instance because it would say, this is a software level change. I need to redeploy these to have it be consistent with the desired state.
Okay, awesome. Yeah, Jad says don't to tell you to stop making VRA feel bad. But you know what? VRA never did all this, so meh.
And it's different use cases, right? Because VRA didn't target this stuff, and VRA still doesn't target this stuff. But guess what? If I wanted to be able to do extensibility, right? If I want to be able to, there's an extensibility tab up here, but it's in beta. If I'm looking at doing integrations with existing environments, right? So I want to interface with an IPAM, like a Infoblox or a BlueCat. If I want to do ServiceNow, if I want to do interfacing with like storage arrays, if I want to do REST calls, all of that stuff, VRA is light years ahead of where CAS is on being able to do that, because that wasn't the target for CAS. Because if you think about it, a lot of those extensibility use cases with public cloud are lessened, right? You're not necessarily, are you tracking your public cloud IPs and Infoblox? Probably not. Are you how much of your AWS resources are you tying back into your on-premises infrastructure? Probably relatively minimal. So while that stuff's going to come to the product, and VR or Cloud Assembly is going to adopt that extensibility and get that when it's not in beta, VRA does that better now because that's the use case for VRA. So when I'm out talking to customers about the product, and Jada knows all this already, and he's probably laying this up to me to say, but like when I talk to customers today, there's a ton of examples where I tell them don't do CAS. It's not for you right now. Your use case is gonna fall apart. People who want governance, right? People who want to be able to do approvals, like the product falls apart for that right now because that was not the target for the product. People who want to do private cloud first, that's not the target. Like, so it falls down for private cloud workloads exclusively, mostly because of the extensibility, which is possible, right? There's VRO integration. We have the ability to tie into VRO. We have the ability to tie into Puppet and do that stuff. But the marketplace is so immature for that right now from CAS because the objects have changed. You know, the InfoBlocks workflows don't just bolt on and work. Right. It's just a different use case. No one's picking on VRA JAD.
So there's a couple of things going on simultaneously. So one of the questions was, is CAS going to replace VRA or merge in the long term? While Jad says that CAS blows VRA away, but VRA will catch up. So it makes me think that maybe not. It won't replace it. It'll kind of maintain it. My question is, would it maintain kind of this model of depending on what kind of who you care about first, right? Public cloud versus private cloud, depending on what is your biggest priority, that's probably going to tell you which one of these two to go with for the long term. It doesn't sound like CAS and VRA are going to merge or one's going to kill the other. So it sounds like for the long term, it's still going to be that your first priorities will judge what you go to.
I would actually say short term. That's the answer. Long term, they are going to merge into a central product, right? Like this functionality is going to come onto on premises, and the capabilities that VRA has will make it into Cloud Assembly today. So it really is more of a merge because, for example, even in my VMware Cody staging environment where I can go in and see early builds, there is no policy engine. Right. So like these are things that CAS is going to adopt. Now it's going to be a different policy engine. It's not going to be a one-for-one copy of VRA. It's redesigned from the ground up. But when you look at features and bullets on what functionality exists in a platform, VRA is ahead of CAS in that. We have a comparison slide that we use internally around how far is each product on these. And for governance and approvals, CAS gets like a 1 out of 5, whereas VRA gets a 4 out of 5, right?
Right.
So that there is things that are going to be adopted into Cloud Assembly, and there are things that VRA is obviously going to adopt. Now, if you weigh those out and say how much of the product is going to be adopted into each, VRA next is going to look like this, like the UI that you see right now, and you can see that in 7.5. The 7.5 deployments tab looks just like this. The VRA catalog looks a lot more similar to what you see in Service Broker. More of CAS is going to go into VRA than VRA is going to go into CAS, but I would still call it a merger.
Okay. Awesome.
So
I have more questions for later. I'll team up a little longer, but
so at this point we've gone through the majority of Cloud Assembly. There's tons more bells and whistles. There's a lot more we didn't touch on around from like endpoints integration standpoint, around like Puppet and so on and so forth. So the ability to deploy Puppet manifests. There's a ton of different blueprints that exist. Just to go follow up on the ESX hosts, those did deploy, although they deployed with a private IP for some reason. So that's interesting, but they did finish deploying. I'll give that a half failure. Because it's not a reachable IP. So if you wanna pick on me, Luis, you can pick on a half failure. I'll give that a half.
Okay.
So we've covered kind of the majority of the use cases within Cloud Assembly. So I'm going to shift gears into CodeStream for the last 6 minutes or so, because we can blow through that relatively quickly. So we'll switch over to CodeStream. So CodeStream is an interesting product because in the earlier generations, it was very much typecast as a pipelines product, and it was very much focused on the developer and how does the developer have code releases happen. But I think that that's changing a lot, and there's a lot of functionality that makes a lot of sense for the infrastructure developer in CodeStream. So the best way to describe CodeStream is that it is a pipelines engine. So if I go into the CMView demo pipeline, I expand this out. When I commit some code to Git, a webhook fires off. CodeStream sees that webhook and initiates this pipeline. It goes out and it builds a series of Docker images. It then goes out and provisions those Docker images to my VKE cluster. It then checks the URL for that load balancer, makes sure that it's up. If it's up, it sends me a notification on Slack. It then sits in an approval state and says, hey, are you happy with this? And when I'm happy with it, it blows it all the way so I can go demo it to somebody else. When you think about how long this process would take for traditional infrastructure to accomplish, it's a pretty big time gap, right? The idea of how long would it take someone to go through and build these 3 containers, get it exposed. If you're a developer who has access to all of this, of course, it's probably 5 minutes for you to go through and do all of that. But in traditional infrastructure where you're working across multiple teams, if you're building 3 servers and deploying these apps as thick apps onto the environment, and then going through and getting the network team to set up your firewall rules, setting up your load balancer, doing your manual checks on the environment, you're looking at probably a several week process. Those are the kind of things that are possible when you use something like CodeStream to actually pipeline this stuff out. And people do this today with things like Jenkins. What you get from doing it inside of CodeStream is you get, one, the native integrations that exist. So if we back out and we go to endpoints, we can see all of those. You get native integrations, and the naysayers in the audience will say, well, Jenkins has those too, but these are all individual plugins in Jenkins. And it's a very common thing that when you upgrade your Jenkins server to shatter all of your plugins and have to go through and reconfigure those. So these are functional pre-configured objects that are able to be integrated with a pipeline. So that's part of the benefit of something like CodeStream. There's a lot of things.
Cody, we lost you. And we're back.
Yeah, unplugged my mic from the computer on accident as I spun in my chair. There's a lot of things that are added here versus the CodeStream of yesterday. So things like Kubernetes, that was a plugin that you could add to CodeStream in traditional VRA, but now it's a native support. PCF, direct Git integrations. So these are all like endpoints that can be configured and resources that can be used by the pipeline engine. A very cool demo that I have around this is some people saw on Twitter recently, I moved my blog publishing. So my blog used to publish through AWS natively, and I'd use Code Build in AWS. And when I committed my code for my blog into my GitHub repo, which I will just pull up real quick. This is essentially my blog, right? So when I would commit code in, you can see I committed a post in yesterday. A webhook would fire off, and AWS would see that and perform a series of tasks against that deployment to have it copy into my environment. Being that I work for the company, I want to drink the Kool-Aid, I built a pipeline around that. It's a very simple pipeline. It's one stage. It's what we call a CI pipeline. And what that pipeline does is it takes that webhook that fires off, it takes a custom Docker image that I built and builds out my blog and then syncs it into S3. And what I get as part of that is I get nifty dashboards that I can see the status of all of that. So I can see all of the times where I was trying to get it to work and failed, and now I can see all the successful pushes. I can get data around it. I'm integrated into my platform. Now, taking this a step further, like this is cool for like a blog publishing. I said earlier that I think that there's a lot of opportunities for this to be relevant to this traditional infrastructure developer. I'm working a lot with Puppet. I'm working a lot with building manifests, and I'm kind of relearning new Puppet because the last time I touched Puppet was probably about 4 years, three or 4 years ago at this point. I'm constantly changing those manifests and growing them and making them better, adding new functionality in. Maybe I'm replacing some of the manual execution steps with more Puppet native execution steps. Imagine this place where I've taken that manifest and I have a webhook set up around that. And every time I commit a change into that Puppet manifest, it goes out and it provisions a new blueprint in Cloud Assembly. It's very common for a person developing VRA blueprints to test out their deployment, right? So I go in, I make all these changes to the way the blueprint's configured. I add new script tasks in, I hit save, I deploy it, and I wait. What if that was automatically configured to run, and then I could also configure tests to run against it as part of the pipeline, right? So it goes out, it builds that integration, builds that deployment, and then checks the URL, checks the IP address to make sure that it's responding with something. So I don't have that functional today. We have 2 minutes left, and I'm going to make a run at setting that up very quickly and see if we can pull it off.
Yeah, you can go over if you need to.
It's not true. We can't go over. We can never go over.
The internet is a vast and infinite amount of resources. Go.
All right. So we're going to go in. We're going to set up a Git endpoint. We're going to use my repo. So we'll go GitHub. That's all set right. We're going to call this infra iteration. I'm going to go github.com, Cody D, and I think I call it Puppet Demo App. I have a branch set up for it that's called Puppet. We'll do a validate, make sure that checks out. Awesome. We create the endpoint, so now it knows about that Git instance, right? It knows about that repo. Now I can go and create a webhook. To create a webhook, I'm going to need an API key, which I'm subsequently going to have to destroy after this and update all of my endpoints so that nobody can hack through my stuff. But I will grab my API key from here. I'll go back into code stream. And now we're going to use that API key to build essentially a webhook into the platform. So we're going to go into Git. We're going to go webhooks for Git. We're going to do new webhook lab. All right, we're going to use that. Oh, I didn't actually build the pipeline yet. So we need to go build a pipeline real quick.
Oh, breaking the demo.
It happens. This is going to be where it falls apart because I've never set this up before. Blueprint. Oh, we need to release it. We can use this one actually. That's fine. So we have all of these different versions in here. So we'll grab version 7. So this wants an input of my SSH key as well as what user to create. We'll just statically set this right now. We're not going to worry about the SSH key just yet. Cool, that all looks good. So what this will do is on input or on deployment, it will grab from Git. So I add this input, so it actually will grab all of that. And hopefully deploy once it sees that webhook fire off. So we'll save. It's not executable because it's disabled, so we will enable it. All right. We'll go into here, we'll create our webhook, new webhook.
Probably people watching, he did not say continue on failure, so I'm really interested to see if this goes through.
Yeah, right. It's a good call. So it understands all of those objects. We're going to create this. Now, what's interesting about this, if I go into my GitHub account, and I go back to that Puppet demo app, I go into settings, and I go into webhooks. It's always going to show an error the first time because it hasn't actually pushed yet. But it created that webhook reference inside of GitHub already for me. So now, in theory, if I go in and edit that blueprint, or edit that manifest. So let's go in, and what we'll do is we'll just change a simple thing inside of here. Actually, I changed the master. I need to change the branch because I changed the wrong one. So now we're not going to sit here and wait for it to actually, we can wait after the recording for it to go through, or we can keep it going. I don't care, but it's going to take a few minutes for it to fire through. So see, it grabbed that webhook. It saw the push. Now, in theory, if we switch over into the pipeline service, we should see our executions. We should see it starting to fire up. It's queued, so it's getting ready to fire off an actual build. Why did it go into that one? There we go. Puppet manifest. There we go. So now, if we switch over into Cloud Assembly, in theory, we should see a deployment being kicked off with it. Eventually.
I mean, I'll give you kudos for that one. That was a lot faster from a setup, from a full setup to run through and.
Oh, there it is. It
nice.
Failed. It failed.
But it still tried.
It still tried. So the webhook was functional. It's likely just some configuration item that I don't know about yet. So.
But that was an API to API. That was strictly just one web service to another talking. API only kickoff from Git to starting a build in CAS, right? Which
Correct.
is awesome. And you didn't have to go and set up or do anything from a Jenkins or anything else, kind of a dependency to get it integrated.
Exactly. So that's kind of the point there, right? It's very easy to marry these services together and accomplish some very iterative and interesting pipeline tasks, right? We could have this from here go out, and as another pipeline step, I had another version of this that would go out to AWS and create a Route 53 reservation at the end, right? It's easy to have multiple integrations in a more pipeline fashion, similar to what you see in VRO from like a bigger workflow perspective, but obviously a lot more lightweight and a lot more integrated than having to pop out and launch a Java client and build a workflow around it. So it's pretty slick.
Yeah. So one last question from somebody watching. Is VCD a requirement for CAS, which I don't think it would be, since that's more of a service provider side, right? It's basically, this is just strictly a service on its own.
I'm sorry, what was the question there?
Is there any requirement for VCD from CAS to function from a connecting or talking to on-prem? What are the pieces that you need to make work on-prem?
Okay, you said VCD and I got confused there for a second. To use CAS for on-premises, there's something called the data collector. So we can go in and we can see that here. So this is an appliance. It's a lightweight appliance that runs on-premises. It has a series of agents on it that do various things. It goes out over 443 to a number of different web services. So like if you were doing like firewall rules in enterprise, you'd have to have a series of URLs whitelisted. But so far, the people I've helped set it up, I haven't had any problems with. But this effectively gives you a gateway to your on-premises builds. So like a number of my endpoints in CodeStream use that in order to communicate back to on-prem. It's basically, think of it like a proxy appliance, right? So it's giving you kind of a gateway, and so you're not having to expose everything directly to the internet. You're exposing it through this appliance.
Okay.
You deploy that, and it's very easy to get started. Another thing to call out that's worth mentioning is you can actually go onto the hands-on lab and play with this full product. Like everything is unlocked in the hands-on lab. You only have the hands-on lab for like 4 hours, right? So, be wary, but the full product is in HOL today.
So a couple last questions before we end for the night. First one is for people who are, historically have used VRA. What are the easiest and the hardest things when trying to consider transitioning into CAS versus VRA?
So I don't think that there's a lot that's like terribly hard about transitioning. There's a lot of definitions that change, right? And there's a lot of things that you were used to meaning something in VRA that mean something different in CAS. Where I see like the challenges come into play are the things that CAS isn't designed to do yet, like the deeper extensibility use cases. If you want to craft a lot of that external communication with outside systems, that gets a little bit challenging.
And the
approval stuff doesn't exist.
Easiest wise would probably be like building blueprints based on the same
Oh yeah,
drag and drop as before.
yeah. John Schulman and I, we were onboarding a customer, and in a 1 hour call, it was a little bit more than that because they had to wait for their blueprints to discover, but they were fully set up with mapped templates within about a half hour of the conversation. So they deployed their data collector, they were able to build their blueprint, have it functional, and then as soon as their collection occurred, they were able to add that blueprint or add that machine to a mapping and consume it in a blueprint. It's very fast to get started with deploying an actual object. And if you were doing like an AWS native one from scratch, it's 5 to 10 minutes to get to a place where you can deploy an EC2 instance, right? Or be able to, especially if you wanted to be able to do agnosticity between Azure and AWS. The on-prem stuff takes a little bit longer because of the appliance deployment. But if you're just focused on public cloud, which again is the main use case for CAS, you could have a front-end service that's able to deploy to both clouds inside of 15 minutes easily.
Nice.
Try to accomplish that in 15 minutes in the existing platform for public cloud, right? Like,
and then, so the next question being, you talked about the hands-on lab, you can play with it in there. You also mentioned earlier that you could demo this for 30 days. What are all of the ways that anybody can get their hands on working with CAS today?
So I actually got John actually sent me a friendly nastygram that it's actually, so during initial availability, the 30-day trial is gated, so not everybody can pop in and try it. On right now at GA, the demo license will be there, so you can go in and do 30-day trial, no problem during GA. During IA, it's a gated thing. As far as all the ways to get to this right now, there's that demo program. If you're doing it as an enterprise, you shouldn't have a problem doing that. You can do the hands-on lab, which is by far the best way to do this. And then other than that, it's buying it, right? It's licensed on a per host or per node basis. So if you have 10 VMs, you're buying 10 licenses. Okay. Those are the 3 ways to get to it right now. But I would highly encourage the hands-on lab. There's going to be, Grant and I are going to do some blog posts around creative utilization of the hands-on lab with CAS, because there's some really cool ways that you can test out CAS using the hands-on lab that will make it very fun to be able to actually use the hands-on lab for it. Nice. It's
kind of like how to jump off the track and be able to go off-roading and test it out in your own way. Yeah. And so the last part is, obviously we talked about this during VMworld in the US, and we're going to talk about it again during VMworld EU. Is there anything else, or any particular sessions or content that people should really look out for? Maybe there's some changes coming that should be talked about. Where they should go to pay attention to
that. I would say, obviously, so we're heavy in the blog space, right? So VMware blogs. I tend to drop a blog every time a major feature comes out, so keep an eye on that space. There's a couple of sessions at VMworld Barcelona that are going to be there, but I don't know if there's going to be any like major announcements that are coming out at the Barcelona timeframe. I would definitely look to the end of the year, early next year, for some big announcements to come out, and I'll probably come back around on this, and maybe I'll drag John out with me to present also, because there'll be a lot of functionality that'll come around that timeframe.
You guys doing any Meet the Experts out there, or anything else around that?
Ton of Meet the Experts going on.
Perfect. Well, Cody, thank you so much for your time tonight. I really appreciate going through this. It's awesome to see where CAS is today. I know it's been talked about for a while, and it's nice to see a live demo of it. If you guys have any more questions, obviously reach out to Cody. Cody, you want to let him know what your Twitter handle is?
Yeah, so you tweet me at Cody De Arkland, so I'll bring it up on the page real quick. So at Cody De Arkland. I also have my blog, so thehumblelab.com. I tend to respond very quickly on Twitter, so definitely tweet me, ask questions. You want to see more, hit me up. The community knows that I love having conversations. I love showing this stuff off, so I'm always around and willing to jump on the fly call around this. So,
and then any other questions, don't go to Jad. So thank everybody tonight for coming along. Really appreciate you guys joining us live. We'll be posting this to YouTube. Again, you can check out more of these vBrownBags at vBrownBag.com. We have these every Wednesday night, and there's additional content coming up ranging across a bunch of different products and different vendors. Have a good night.
Thanks, guys, for coming.